Okay, so we have different angles that we have touched on. We've touched on central and inscribed angles today. In the past, today you're going to learn about two new ones. So central angles, a little bit of a review, has a vertex at the center of the circle. The angle and the arc are equal or congruent. So what does this look like? It's like if I had center point here, and there's my angle. If the central angle is 100 degrees, the arc is 100 degrees. So here's your formula, angle equals arc. On your formula test, that's what you'll be responsible for writing down. If you like to make flashcards, this is what I would put on my flashcard.
You have a formula test?
You have a formula test, yep. There's 10. Okay, inscribed angles. Done these before. The vertex for this is on the circle. Vertex is on the circle. So your formula is angle equals half of the arc. The more you use them, the more it's like, I didn't actually have to memorize that because I put it into action so much. So for this one, it's be something like this. So this time if my angle was 50 degrees, my arc would be 100 degrees, twice it. Your two new ones for today. Interior angle. So interior on the inside. So not central angle is on the inside, but this is one that is not including the center point. So an interior angle is formed when two chords intersect. So for example, it would look something like this. I'm going to give these letters just so we can kind of talk about it as an example. If I give this A, B, and C. My angle, so A, equals 1/2 of the arcs added together. So angle A equals 1/2 of arc B plus arc C. Exterior angle. So this is exterior on the outside. This is an angle formed when two secants or tangents intersect. Secants or tangents, meaning outside of the circle. So if I kind of sketch what that could look like, so this line would be a tangent because it doesn't pass through the circle, just touches the circle at one point. I could keep it going on forever, does not quite matter. And then if I create a secant here, I'll label these A, this arc I'll label B, this arc would be C. The angle outside, we use subtraction. So the angle equals 1/2 times far arc minus close arc. We should get a positive number when we do this subtraction. If you don't, then you did it wrong because it should be big minus small. So in my letters here, angle A equals 1/2 times far arc, so arc C, minus arc B. When you're ready, flip the page over. Okay, so we have to decide what kind of angles these are. So these angles are being created. I do have a something passing through the center point, but there is no angle created with my center. So these angles are on the circle, inscribed. All right, so I need to find arc FA, and I need to find arc HA. Well, I can tackle FA first because angle H here is opening up to arc FA. So the angle equals half of the arc. So if I multiply 56 times 2, what's 56 times 2? 112. So FA is 112. And then I'm noticing that FH is a diameter. So if FAH is a semicircle, then to find HA, I'm going to take 180 minus 112. Should get 68 degrees. Questions? All right. Number 2. So these angles are inside my circle. They are not passing through the center though, so these would be called interior angles. So angles on the inside equals 1/2 times the sum of your arcs. So this angle on the inside, 121, equals 1/2 times, and I might even just write above it, arc plus arc. So adding these two things together, 64x plus 17x minus 1. So 121 equals 1/2. I'll combine my like terms in my parentheses. 64x plus 17x, 81x minus 1. Then you need to distribute your 1/2. So 81 times 1/2 is 40.5x, and then -1 times 1/2 is -1/2. Probably should just use 0.5, so I'm keeping consistent, staying with decimals. Subtract 1/2, so I have 120.5 equals 40.5x. Divided by 40.5, so x equals what? 120.5 divided by 40.5. Tell me what I did wrong. Andrew? Yep. So right here I subtracted 0.5 and it's already minus, so I should have added. So this actually should be 121.5. Now if we divide, we should get a cleaner answer. Should just get 3. Now I'm tasked with finding arc DJ. So I'm going to plug it in for x here. So 17 times 3 minus 1. Abby, what'd you get? 50 degrees. Very good. Okay, number 3. So these ones are a little bit, they don't look like your traditional inscribed angles, but this angle is on the circle. So this would still be considered a interior or inscribed angle. So if this is inscribed, then the angle is half of the arc. So this angle K is opening up to arc KJ. So your angle equals half of your arc. So if my angle is -4 plus 11x, that equals half of my arc, so half of 80. If you wanted to just kind of compute that and set it equal to 40 right away, you could. -4 plus 11x equals 40. Add 4 to both sides. 11x equals 44. Divide by 11, so x equals 4. Questions? All right. Number 4. So anytime we see an angle outside, we're going to be using subtraction. So writing my formula should be angle equals 1/2 times far arc minus close arc, or big arc minus small arc. Probably add exterior angle up here. So my angle is angle U, 21x plus 5 equals 1/2 times. My far arc is 7x minus 2, or 73x minus 2, minus our close arc, this time it's just 81. So you might think like, oh, why did you put that in parentheses? If this was anything other than 81, so if it was like 2x plus 3, I have to distribute this minus sign to each term before I do the subtraction in my big parentheses. So let's start to simplify. 21x plus 5 equals 1/2. 73x. -2 minus 81 is -83. Two options here. I see right now that if I multiply these by 1/2, I'm going to get decimals. So I could either distribute these and multiply by 1/2, or I could undo this multiplying by 1/2, which is dividing by 2, and I can multiply both sides by 2. That way, this half would go away, and these would become larger numbers instead of getting decimals. Either way works. We'll go ahead and distribute and get decimals, and then next time I'll show you the other way. So 21x plus 5 equals 73 times 1/2 is 36.5x. 83 times 1/2 is 41.5. Combining our like terms, so I'll bring my x's to the right just to keep them positive. 36.5 minus 21 would be 15.5 x. 5. I'm just making mistakes all over the place. This should have been negative 41.5 because it was already negative. Now if I add 41.5, 25 plus 41.5, so 46.5, divide by 15.5. You guys let me know what you get. $46.5 divided by 15.5. Three. Yes. So then I asked you to find arc TS. So we have a couple more steps here. So TS is here. In order to find TS, I need to find major arc from V to S. So I'll plug that in. So 73 times 3 minus 2 and I'm getting 217. Now for TS, I would take 360 minus 217 minus 81. And I got TS is 62 degrees. Questions? All right. Number 5. What kind of angle do we have?
Interior.
Interior, angle on the inside. So the formula for this is 1/2 angle equals 1/2 arc plus arc. So my angle is 23x plus 5 equals 1/2. Then I'm going to add these two arcs. So 50 plus -5 plus 39x. 23x plus 5 equals 1/2 times 50 plus -5 would be 45 plus 39x. So I'm going to picture this right side as being either multiplied by 1/2 or dividing by 2. In order to undo that, I would multiply both sides by 2. When I do that on the right, my fraction goes away, and this is going to allow me to not have fractions or decimals. So distributing this 2, 23 times 2 would be 46x. 2 times 5 is 10 equals, then I'll just have 45 plus 39x. If you don't mind dealing with 0.5s, it's not a big deal, then you can just continue with the method that we did in number 4. Combining our like terms, so let's subtract 39 on both sides. 46 minus 39 is 7x. Subtract 10 and get 35. Divide by 7, so x equals 5. Now let's see what arc we're tasked with finding, or angle actually. So we want to find angle LMK, so right here. So let's plug in. So we have 23 times 5 plus 5. What do we get? 120. Three more. Okay, this angle has a vertex on the circle. So what do we call it?
Inscribed.
Inscribed. All right. So angle K here is 2x plus 17. It is opening up to arc KJ. I don't have a ton of information other than I have this major arc from K all the way around to J. So what I have to do is kind of manipulate things here a little bit. I need to find out what X is. In order to do that, I'm going to rename KJ. I don't have a name for it right now, or variables. I do know that KJ will be twice of angle K. So if I take 2x plus 17 and multiply that by 2, I'll be able to have a expression for arc KJ. So this would end up be 4x plus 34. Now I have an expression representing the entire circumference all the way around. So 27x plus 16 plus 4x plus 34 should be equal to how many degrees? 360. So we didn't have like a set formula to set that equal to, but we had to kind of recalculate. Questions on setting up that equation. Okay, let's combine our like terms. 27 plus 4, 31x. 16 plus 34, 50, equals 360. Subtract 50. Divide by 31. X is 10. Then I asked you to find arc KJ, which we have this expression for. So I'll plug in 10. So 4 times 10 plus 34. So 40 plus 34, 74 degrees. All right, 2 more. Number 7. What kind of angle is this? Inscribed. We're stepping back a bit. All I'm asking you to find is angle K. Your angle equals what in relation to our arc? Half of our arc. So my angle X equals half of 176. Do I need to set up that equation? Probably not. What's half of 176? 88 degrees. Last one. What kind of angle do we have here? The angle is created outside the circle, so exterior angle. So my formula for this, Dalton. Angle equals 1/2 of far arc minus close arc. So my angle is 4x plus 6 equals 1/2 times far arc is 15x minus 10 minus my close arc. It's just one term, so I'm just going to write minus 48. If that was a binomial, I'd have to put it in parentheses, distribute. So I have 4x plus 6 equals 1/2 times 15x minus 58. Which did you guys like better, multiplying by 2 or just distributing the half? Multiplying it? Okay. So if I multiply by 2, that goes away. I would multiply by 2 over here. So I'd get 8x plus 12 equals 15x minus 58. Subtract 8x, 15 minus 8 would be 7. 12 plus 58 should be 70. Divide by, I'm missing x, 7x. Divide by 7, so x equals 10. Then I asked you to find measurement of angle ACL. ACL is our exterior angle. So I have 4 times 7 plus 6. So 28. Why did I put 7 there? Losing my mind. 4 times 10 plus 6. 40 plus 6. 46 degrees.